Welcome to Algebra 2 2.0. We're starting over. So, today in MathXL, we are going to cover sections 1.1 and 1.2. So, today's lesson is patterns and expressions. So, let's do a basic math review. So, we have, first, just our basic, what's 2 plus 3? It's 5. 3 minus 4 is 9, or 13 minus 4 is 9. Okay, now let's go over a quick, just basic algebra review for solving equations. Okay, I like to draw my line. We're solving for our variable, whatever variable. In this case, it's x. Okay, so we have to undo our subtraction by subtracting our 3. Cancel, cancel. X is equal to 0 minus 3 is negative 3. Okay. Next, we have b minus 2 is equal to 3. Draw the fence, solve for b. Add 2 to undo your subtraction. We get b is equal to 5. Good job. Okay, Algebra 1 review. 2m plus 3 is equal to 5. Draw my line still. Okay, now we're going to we have to undo our addition or subtraction and then undo our multiplication. Here we're going to subtract 3 from both sides. Bring down the 2m is equal to 5 minus 3 is 2. Now we undo our multiplication by dividing by 2. Those two cancel. 2 divided by 2 is 1. Okay, next we have variables on both sides. What I personally like to do is I like to move variables to the left, numbers to the right, then solve, okay? So first I'm going to subtract my 2q from 4q, okay? We could not have done it to the negative 4 because those aren't terms, okay? So be careful with what you subtract or add it to. These cancel, bring down negative 4. 4q minus 2q is 2q, and that equals positive 4, okay? Now we add 4 to both sides. Cancel, cancel. So 2q is equal to 8 divided by 2. Q is equal to 4. Okay, cool. Let me erase this really quick. Okay. So now let's talk about some key terms. So first we have constants. Constants are quantities that values never change. Constants are always numbers. Okay, 3, 5, 7, negative 4, negative 11. These are constants. A variable is a symbol or a letter that represents one or more numbers. So an example would be n. Okay. A numerical expression is made up of numbers and symbols. 3 plus 5. An algebraic expression is a number variable in symbols, so like 3n plus 5. So variables and expressions. So if we have patterns, these can be represented by expressions. So if we look here at this pattern, these are toothpicks. So we have 1, 2, 3, 4 toothpicks. And then this pattern increases, we have add another of 1, 2, 3, 4. 1, 2, 3, 4. So we have a total of 8 toothpicks. And then if you look here, we have this 4. We have this 4. We've added another set of 4 toothpicks. Okay, so now we have 12 toothpicks. So we can represent this relationship, this pattern, with a table. So how many toothpicks are in the 20th figure? So we have two options. We can either lay out toothpicks 20 times, increasing by 4, or we could use math. Let's try that one because that's not as many toothpicks. Because what if we wanted to find the 1000th figure? It'd be a whole lot easier to figure out the math behind it instead of laying out a zillion toothpicks. So you're going to use a table to represent this, what we already have, and then see if we can figure out an expression that represents this. So on figure number 1, we have the process in figure number 1. We're multiplying by the input of 4. We're inputting 4 in each new figure. So we have 4 here. So 1 times 4 is 4. Here we have in figure 2, which is our input, we have 1, 2, 3, 4, 5, 6, 7, 8. So figure number 2 times our input of 4, we get 8. Okay, we have our output, our input of 3, and we have our output. We multiply the input by 4 in order to add our 4 toothpicks. Okay, so we could represent this by saying if we're multiplying 4, so what we're adding to the figure number. So this could be represented by n amount of toothpicks. So this we could say figure number n times 4. Well, that doesn't look as pretty. Let's algebraically say that's just 4n. So if we wanted to figure out the 20th figure, that would be 20 times 4, which 20 times 4 we know is 80. Okay? So if we wanted to figure out any figure number, we just would multiply it times 4, because that's what we're adding each time. Okay? Lesson 1.2, properties of real numbers. We've talked about this, in our first 3 weeks, talk about like all real numbers. You guys have heard me say that with domain. And so let's talk about what these mean some more. So here is properties of all the numbers. Like we said, real numbers is every number, okay? But not every number is a counting number, or a natural number, or a whole number, okay? So let's talk about what each individual. So I'm going to start at the top. So the most specific are the natural numbers. So whenever I say, okay, count to 10, naturally you start at 1. Okay, so same with your natural numbers, it's just 1, 2, 3, 4, 5, 6. Those are the first numbers that you guys learn. Those are your natural numbers, starting at 1, 2, 3, okay? Then we add the whole numbers. So it's all of the natural numbers, but we add 0. I like to think that's your whole. Okay, your whole number has your whole with it, but it's also, it includes your natural and your whole with the 0. Okay, integers are all whole numbers and their opposites. So what all that is all the negative numbers, 0, then all your positive numbers. Okay, so your natural numbers, 0, which makes it all your whole numbers, and then all the negatives. Then we have rational numbers. Rational numbers can be defined as a ratio. Okay, so like a fraction. Okay, -1/2. That's a fraction. That's a rational number. If we change that to a decimal, it would be -0.5. Okay, there's not a stopping point. So you have rational and you have irrational. Rational numbers are values that either have a natural repeat, okay, or they have a distinct stoppage, or they can be represented as a ratio. So like 1/3, that is a rational number. If we changed 1/3 into a decimal, it would be 0.333333333. It has a natural repeat, so that means that it is a rational number. Okay, an irrational number would be something like the square root of 2. Okay, I'm going to, real quick, in our calculator, if we put the square root of 2, that translates to 1.414213562. There's no repeating, okay? There's no pattern there. So that means that that's an irrational number. Okay, think of pi, 3.1415926. It goes on forever. Just random numbers. There's no natural stopping. There's no natural pattern. So therefore, that's an irrational number. But all of these numbers are real numbers. So some properties. Now we're going to talk about graphing numbers on a number line. So what is the graph of the numbers -5/2, the square root of 2, and 2.6? Okay, I think that graphing numbers on a number line, and same with a graph, are a lot easier if you put them into decimal points. Okay, so since -5/2 is 2.5, -2.5, so that's between -2 and -3. So I always think -2.5. Okay, I prefer decimals for this. -2.5, that's halfway between -2 and -3. So your dot would be between -2 and -3. Okay, the square root of 2. If you use your calculator, we've already done that one. We know it's irrational because there's no pattern or there's no stop. It's 1.4142. Well, that, if we round that to the nearest tenth, that'd be 1.4. So it's almost between one, it's like almost halfway between 1 and 2. So between 1 and 2, we're going to go almost halfway between. And then 2.6 repeating, so that's like 2 2/3. This is a rational number because it can be represented as a ratio. So we go 2/3 of the way between 2 and 3. 2.6 is a little over halfway. Okay, so that's how we can represent those. So in green, I'm going to represent what is the graph of the numbers, the square root of 3. Okay, so the second square root of 3 is 1.73205. Okay, so that is 1.7. Okay, so 1.7 is a little over halfway between 1 and 2. So that a little halfway is there, so right there. It's closer to the 2 than it is 1. Okay, negative 1.4 repeating. Okay, since this is repeating, so let me reverse a little bit. Irrational number. Rational number, because of the repeating, okay, it has a pattern, not negative 1.4444. It can be represented as a ratio. So that is between negative 1 and negative 2. Okay, it's not quite halfway. It's so the negative 1.4, the square root of 3, and now 1/3. 1/3 is 0.333 repeating. Also a rational number. That is 0.3, so that's between 0 and 1, and it's a third of the way through. Okay, and so that's how we represent things on a number line. Okay, this will become really handy whenever we're graphing. Okay, so now let's talk about the properties. So we're gonna talk about these a lot throughout Algebra 2. So the properties of real numbers. Remember, every number is a real number. Okay, so if A, B, and C represent real numbers, let's talk about addition and multiplication, some properties. So the closure property. It means if A is a B number, A is a real number and B is a real number, A plus B equals a real number. Okay, so if you have 2, real number plus 3, real number 2 plus 3 is 5. Same with multiplication. If A is a real number and B is a real number, A times B equals a real number. Okay, commutative, sorry. If A plus B equals B plus A. Okay, so it just means like if you have 2 plus 3, that equals the same thing as 3 plus 2. With all of these, I always like to represent them as real numbers. Okay, so if 2 plus 3 equals 3 plus 2, they both equal 5. Same with multiplication. A times B is the same as B times A. 2 times 3 is 6, which is the same thing as 3 times 2, which is also 6. Okay, associative. A plus B plus C is the same thing as A plus B plus C. Okay? If you notice, there's only addition here. It does not work with subtraction. Because remember, subtraction and negatives, they're just ruin lives. It's not the same. You cannot do, there's no associative for subtraction. It's just addition. So, if we have, let's put numbers here. 1 plus 2 plus 3. 1 plus 2 is 3. 3 plus 3 is 6. Okay? 1 plus 2 plus 3. Well, here with PIMDIS, we would do 2 plus 3, which is 5. So 1 plus 5 is also 6. Okay? It would not work with subtraction. Okay, same with multiplication. If we have A times B and then multiply times C, it's the same thing as A if we multiply B and C first. Okay, we have additive identity and the multiplicative identity. Additive identity is if you have a number and you add 0, you still get that number out. So if you have 100, you add 0, you still have 100. Okay, multiplicative identity, if you have a number and you multiply it times 1, you still have that number. So the identity is if you multiply by 1, you get the same, have the same number. Add 0, you have your same number. Okay, and then the inverse is opposite. Okay, so A plus negative A is equal to 0, and you always get the 0 out, okay? Or it just means A plus negative A cancels. Okay, you get 0. Here, whenever we cancel with multiplication, we get 1. So this is like the reciprocal. Okay, if you have a times 1 over a, or you multiply it by the reciprocal, where a can't equal 0, then you get 1 out. Okay, and then the distributive property, we have a times b, a times c, that's the same thing. Okay, a times b plus c is the same thing as a times b plus a times c. Okay, and I think that is it for the lesson. So your homework as assignment is in MathXL, which if you're a virtual day, we'll get there should be a video with Mr. Thomas explaining how to get online. If you have questions, email me. Okay, same with Mr. Thomas's kids, email him if you have questions. If you're in class, then obviously we're going to be doing this together and I'll get you on, or if you're at home, you need to figure out how to get on MathXL. We have our new Google Classroom. We're using MathXL. Edgenuity is done. It's in the trash can. We are never logging on to Edgenuity again. So be done with it. Good riddance. Peace out. We're done. Okay, we're on MathXL now. So if you have any questions, if you need help getting onto MathXL, reach out to your teacher and we'll get you all squared away. Okay, I hope that this is going to be better. Well, I know it's going to be better. I think everyone's going to be a lot more successful and we're going to do great. Okay, thank you.